welcome back. In this section of the series, we'll be talking about an assembly, what an assembly is in the .NET platform. In the .NET platform, an assembly is basically a combination of types and resources built to work together to form a logical functional unit or a composite functional unit in the .NET platform. An assembly is a collection of types and resources that are built together to work together and form a logical unit of functionality in the .NET platform. And assembly can either take a form of a .dll or a .exe file. Now, a .dll file basically represents a dynamic link library, and a .exe file is an executable file. So the end product of every project and its source code in the .NET platform are built into, when you perform a build operation, the end product is usually an assembly, and the assembly can either take the form of a .dll or a .exe file. These .dll or exe files contain a collection of the various types used by an application or that can be called by your application or other applications, and the content types such as interfaces, classes, enumerations, and every other member of the type system in .NET. Assemblies in the project bin folder are sometimes referred to as binaries. So every project has a bin folder, and the end product of your project in the bin folder is usually referred to as an assembly, or the binaries there are usually referred to as an assembly. So all your projects are compiled into an assembly, and that is the feature in .NET. That is the end product of all your projects in .NET. Sorry, not a feature, of all your end products in .NET. So assemblies are the building blocks of all .NET applications. Every .NET application must compile to an assembly, and the assembly can either be a .dll or a .exe. So a .dll, remember, is a dynamic link library, and a .exe is an executable file. Executable file in the sense that when the user sees an icon in the desktop and double clicks it and it runs on Windows, that is an executable. So typically assemblies are the building blocks for .NET applications. They form the fundamental units of deployment, version control, reuse, activation, scoping, and security permissions for .NET based applications. So as I said earlier, every project with its source code in the .NET platform are compiled into an assembly. We use the word build into an assembly. That is what we use. So basically an assembly can be built with one or more source code files. So you have your source code files or resources. Let me use the word resources. So either a resource or a source code file, an assembly can be built with one or more source code files. And assembly has the following features. It can be implemented as a .exe or a .ddl files. That's the only way an assembly can be implemented as in .NET, in the .NET platform. And assembly can be shared. You have a project, you can build an assembly that can be shared, which is a dynamic link library, can be shared across multiple projects or multiple applications. Assemblies are only loaded into memory when they are required. Like if you're not using an assembly, the .NET runtime will not load it into memory. So assemblies are only loaded into memory when they are required by a particular application or by another library that is referencing them. Programmatically, we can obtain information about an assembly using reflection, which is a topic I will cover. I'll cover reflection in the part 2 of this series, so you can see how you can have access to how you can use reflection to understand the various types you're dealing with, and probably even call type members that are inside a particular assembly or a particular class using reflection. And another thing I want you to understand is that you can load and inspect an assembly using the metadata load context class in the .NET platform. So those are the basic features you should understand and know about an assembly. So the next thing we're going to consider is, from the definition of what an assembly is, which I told you assembly is a collection of types and resources, what basically are types? That is the next question. So types are basically an attribute of a data. So in this context of programming, data here is considered to be an instruction. So a type is an attribute of an instruction which tells the compiler or an interpreter how you intend to use it. There's a typology there. A type represents a structure, nature of the data which you can process. A type can be numeric, alphanumeric, decimal, or even something you personally created using the features in the .NET platform. Now, my ideal representation or meaning of a type is a terminology used to establish the various constructs, which are structures and attributes associated with data, in this case an instruction, within a programming language or technology. So every programming language there has a notion of what we call data types, and that notion is what defines the type system in a particular programming language. And the .NET platform is similar in that regard. It has a type system that defines the types, the data types that are applicable in the programming, in the development platform. So the data type in programming language are often referred to as types, and that is what we mean in this context. And the next thing we'll talk about is the resources. What are resources? Resources are basically an external file your source code has access or utilizes to perform some kind of instructions. I like the second definition. A resource is a non-executable data that is logically deployed with an app. A resource might be displayed in an app as error messages or as part of the user interface. Resources can contain data in a number of forms, including strings, images, and persisted objects. So that is the meaning of resources. So types and resources are used to form a logical unit of functionality, which we call an assembly. So types and resources make up what we call an assembly. So an assembly can either take the form of a.exe, which I told you earlier, which we refer to as an executable, or a .dll, which we refer to as a dynamic link library. And these are the building blocks of .NET applications. All your projects and its source codes are compiled into an assembly. So this provides the CLR with the information it needs to be aware of regarding the types implemented in that assembly. Now you know what we mean by types. The executable is basically a computer file that contains an encoded sequence of instructions that the system can execute directly when the user clicks it. So you have every icon on your desktop translates, no, most icons on your desktop, not every, translates into an executable file. So for instance, if you have a PowerPoint application or a video application that is running on Windows, or image editing application, that file basically is a .NET.exe file. That's why you can click on it and it will execute and run the application for you to use. The next thing is a dynamic link library. A dynamic link library are shared resources that our applications, various more than one application can use. So you have a functionality packed into a library and it can be shared by multiple applications. So a DLL is a library that contains code and data that can be accessed by more than one program at the same time. And the second definition is what I like most. A DLL is a collection of small programs that larger programs can load when needed to complete specific tasks at the same time. If you check at the bottom of your screen, on the right hand side, you will notice that we have a payroll application .payroll application DLL. You have a payroll database and payroll domain and SeedWalk DLL. So these are typical assemblies that I personally built myself and I use in my projects. All right. So the next thing we'll consider is an assembly manifest. So what is an assembly manifest? An assembly manifest is simply the table of contents that contain information regarding your assemblies. That's what it is. It contains the assembly's identity, its name and version. It contains a table that shows the various information about the type of assembly this is and the resources it utilizes. An assembly reference list, it contains an assembly reference list. If you are referencing other assemblies in your project, it also contains information about them. And because assembly contains information about content, versioning, and dependencies, the applications that use them don't need to rely on external sources such as the registry or Windows to function properly. Assemblies reduce DDL conflicts and make your application more reliable and easy to deploy. This is basically information about an assembly manifest. You can read it, pause the screen, and go through it. So the next thing we will talk about is, okay, so what is it? So we have a single file assembly, and we can have a multiple file assembly. The analogies on the screen show you single file assembly, one source code file, multiple file assembly, a source code file, and some other resources like a graphic JPEG file or a logo bitmap file. So all this information about your resources and types are maintained in an assembly manifest. And typically an assembly manifest has this following information. The screen capture was gotten from Microsoft's documentation. So we have an assembly name, we have a version number, we have a strong name information about an assembly, and all the information that possibly an assembly could have in your application. All right. To use an assembly is simple on the right. Basically, we use an assembly by referencing it. You reference it by adding the assembly to your application, and once you add an assembly to your application, all the accessible types, properties, all the type members, accessible type members in that assembly or in that namespace are available for your application to use as if it was part of your source file.